We're asked in this problem to find and classify all local extrema of this function. And in order to do that, we're going to have to take some derivatives. So first of all, we have f of x, taking the first times the derivative of the second, e y to the minus x. It's going to give us a negative out front, plus the second times the derivative of the first with respect to x is going to be y. So now factoring out, we've got, let's just rearrange this first, y e to the y minus x y e to the y minus x. And let's go ahead and simplify and factor out the y to the e y minus x to 1 minus x. Next we need our f of y. Again, we take first times the derivative of the second. This time y is positive, and then plus the second times the derivative of the first. And then we can simplify this and also take out the x to the e y minus x. And then here we have y plus 1. So now we have our first partial derivatives, and we can find our critical points. And to do that, we need to find out where this equation is going to be equal to 0. Well, e to any power is never going to be 0. However, if y is equal to 0, or if x is equal to 1, it would solve this equation. So let's go ahead and plug these points in here and see what we can get for actual coordinates. Let's take first the x equals 1. What would y have to be in order for this to be equal to 0? If x is 1, well, that's not going to be 0. So our y would have to be negative 1. So that's one of our critical points. And then the other, if y is equal to 0, well, that's not going to be 0. X would have to be 0. So that's our other critical point. Now we need to find the local extrema. So we need to classify these points. And in order to do that, we have to take more derivatives. Let's begin with f xx is going to be equal to, and we'll go ahead and use this guy over here. We'll take in these two parts first. Oops. Times the derivative of the second is just going to be negative 1. So we have a negative out front, and then plus the second times the derivative of the first is going to be then just y e to the y minus x. And then since that's a negative x, we have a negative that comes out front here. Let's go ahead and simplify this out. Well, we can remove negative y to the e y minus x from both of them, which would then give us 1 plus 1 minus x. It's going to be then 2 minus x. Okay, so that gives us our fxx. Now, fxy. Let's use this equation here. It's going to be in several parts. So for that, we take the first times the derivative of the second plus the second times the derivative of the first is just y, so that's going to be 1. Then we need to subtract And here we have x, y, so we're going to do first times the derivative of the second plus the second times the derivative of the first with respect to y, then is going to be our x here. Let's factor this out just a little bit, see what we can get out of this. Let's factor out from here. Let's do it this way. If we take out y e to the y minus x, that's going to leave us 1 then minus x. Then for the second terms, let's go ahead and add, and these have a common e to the y minus x. Then for that we've got 1 plus x. Okay, I'll just take it that far. And then next we have f y y, and let's use this. And to do that, again, we'll do x e to the y minus x times the derivative of the second is just 1, and then plus the second times the derivative of the first with respect to y. That's going to be we're looking at the same thing again, e to the y minus x. Okay, so again, yeah, we have the same thing where we're going to be factoring out x e to the y minus x. And so this then is going to be 1 plus y plus 1, and we can put in y plus 2. Okay, so that's given us now the second derivatives that we need. And in doing this test, remember our formula is fxx times fyy minus fxy squared. Now we need to evaluate it at our two critical points here. So first let's do the 1, negative 0. Come on, pen, don't fail me now. 1, negative 1, sorry. And so what we need to do now is plug it into our formulas here, and we'll see what we get. So with this, if we plug in x is equal to 1, this is just going to give us 1, so we don't need to worry about that. And then here the y is negative 1, so that becomes a 1, so we don't have to worry about that. So now we have the e, and we need to evaluate the power y minus x. So that's going to be negative 1 minus 1. That becomes e to the negative 2. And then times fyy evaluated at this point. We've got y is minus 1, so that becomes 1. X is 1. And so now we have e to the y minus x again, which is going to be e to the negative 2. And then we are subtracting the square of fxy. So plugging our points in here, let's see, we have, well, x minus 1, or 1 minus x here. Since x equals 1, that's going to become 0, so we don't have to worry about that side. And over here, it is 1 plus, wait a minute, I'm sorry, I made a mistake on my signs here. This is supposed to be minus because that was the minus sign. Okay, and again, okay, yeah, that makes a little better sense because now that is also at x equals 1, that becomes 0, so this is going to be minus 0. So at this point, it evaluates to e to the negative 4. then to find out what kind of point is, we need to compare it to 0. Now with this, it's not much greater than 0, but it is greater than 0. So we know it's going to be either a min or a max. And in order to find that out, we need to evaluate what the f of fxy is, or fxx. Look at what the fxx was, and that was this point here, and compare it. And since e to the negative 2 is also slightly greater than 0, that means that this becomes a minimum. Okay, next we need to do at the point 0, 0. Okay, and let's plug that in. And to fxx here, well, y is 0. So we know right away that's 0 times, and then we don't need to worry about the other is 0 because we just multiply them. But now we have the fxy, which then gets squared here. So what does this evaluate out as? Okay, y is 0, so we don't have to worry about that. We now have x is equal to 0, so that's 1. So we're looking at y now to the 0 minus 0. Well, e to the 0 is going to be 1. 1 squared, of course, is 1. So that then is less than 0. And knowing that that's the case, we see that 0, 0 is a saddle point. And with just a couple of bubbles, I got you your answer.